All right, 7.7, part 2, factoring special products. We just got done discussing difference of two squares, so now we're going to look at perfect square trinomials. Okay, so we're going to look at another pattern here. Oh, sorry, it's Mike. Okay, so we looked at a previous pattern. So now we're going to look at this new pattern that kind of crops up when I take a binomial times itself, like x plus 2 times itself, x plus 2. So when I multiply this out, I end up getting, when I distribute, we get x squared plus 2x plus 2x plus 4. So then I get x squared plus 4x plus 4. Important thing to notice, this first term is just the square of the first ones. And this last one is just the square of the last ones. And we can write this x plus 2 times x plus 2, a shortcut way is x plus 2 squared. This is what it means by a perfect square trinomial, meaning I take something times itself, and this is what I get. This is the trinomial I got from multiplying x plus 2 times itself. And if you can notice this pattern, for example, if I take, let's take 3x plus 5 times itself, 3x plus 5 squared. So that would be 3x plus 5 times 3x plus 5. So 3x times 3x is 9x squared, plus 15x plus 15x plus 25. So then when I put my like terms together, I get 9x squared plus my 15 and 15 make 30x plus the 25. So if we can notice this pattern, when I take 3x times itself, or square it, that's where this comes from. The 25 comes from squaring the 5. And this 30 comes from having the 3x times the 5 and 2 of them. So if you can notice that pattern, it can save you a little bit of time. But to be completely honest with you, I very rarely notice that pattern. What I notice is I'm always looking for perfect squares. Because if I have perfect squares, I know it factors by difference of squares, difference of two squares, and that's a nice pattern. So I'm always looking for perfect squares. So in factoring this one, we have n squared plus 8n plus 16. The first thing I'm going to notice is this n squared is a perfect square. That's the square of n. This 16 is the square of 4. So, but I've got a middle term. So I'm going to guess and check, try factoring this using n plus 4, n plus 4. So I'm going to guess and check. So I used guess and check. But since they were both squares, I'm trying the square root of them. Okay? And then now we need to do the check. So n times n is n to the second, plus 4n plus 4n plus 16. So I get n to the second plus 8n plus 16. Yay, it worked. So I'm like, all right, awesome, it worked. I got it to multiply out, but we need to notice that these are the same thing. So I can write it as n plus 4 to the second power. This is the shortest way of writing it, n plus 4 to the second power. Okay. So again, I keep looking for those perfect squares. Well, here I'm noticing this is a perfect, so we're going to factor 4x squared minus 12x plus 9. 4x squared is the square of 2x. 2x times 2x is 4x squared. 9 is the square of 3. 3 times 3 is 9. So I'm going to guess and check this, and I'm going to use the 2x and the 3. So 2x gets me the 4x squared. We'll try 3 and 3. But unlike this last one, everything was adding. Add. This one has a negative. Subtract. So instead, I'm going to try subtract and see what happens. Again, if it doesn't work, we'll try something else. So we're going to guess and check. So now we got to check it out, make sure it worked. 2x times 2x is 4x to the second. 2x times negative 3 is negative 6x. Negative 3 times 2x, negative 6x. Negative 3 times negative 3 is positive 9. 4x squared, put together these like terms, minus 12x plus 9. It worked. So then now I just need to notice these are the same thing. So I'd write it as 2x minus 3 to the second. Again, just noticing patterns. Okay. All right. So next, I want you to do page 401, 16 through 22, even.